Um, Trilce is an assistant professor in supply chain management and analytics at the University of Missouri St. Louis. She works on optimization, econometrics, and statistical methods to find and improve supply chain and humanitarian logistics systems. Trilce is an award winner, scholar, and she has been participating in different type of projects from state, federal, and other sources. She has a background in computer science and a PhD in transportation engineering from Rensselaer Polytechnic Institute and also the Center for Infrastructure, Transportation, and the Environment. So I'm very excited about having Trilce today. Hopefully the next time it's in person. But yeah, Trilce, thanks again for joining us, and we are all yours.
Thank you for the warm welcome, Miguel. I'm very excited to be here. Let me start sharing my screen. I'm really excited to be here. I'm going to be talking about work that I did while I was doing my PhD program at the Rensselaer Polytechnic Institute, where we achieve the quantification of environmental impacts of our deliveries. So today I've been asked to start my presentation talking a little bit about me, and I'm just going to do that very briefly. Miguel introduced me already very nicely. I don't want to take anything away from his introduction, but I'll say a couple things. Then I'm just going to set the stage for the research that I'm going to present, discussing Offhour delivery programs and their motivation. And we're going to dive right into the research of estimating the environmental impacts of these programs. I'm going to touch on the GPS data processing because that's another world on its own. And I'm going to discuss results. So feel free to ask questions along the way. So like Miguel said, I have a background in computer science. I'm from the Dominican Republic originally, where I did my undergrad in systems engineering and computer science. And then I went into a math department right away after that for my master's and just went to work in industry for around 7 years. And while I was working in industry, the research bug, had bitten me while I was doing my first master's. And I was like having like that nagging, inclination towards going back to research and trying to do, academia. However, in Dominican Republic, there's not like that big infrastructure that you have in the US. And that meant that I had to move to the US, which was hard at that point. I have 2 boys. They were born already. So it was like a really big, major life decision. But at some point, my advisor I was introduced to who ended up being my advisor, same as Miguel, Professor Holguin Veras. And I feel very fortunate that I got to do my PhD with him. I learned so much and I got to work in so many different projects. He also kind of converted me to this transportation side. So before I worked with him, I worked in industry and in the public sector doing mostly statistical analysis and analytics consulting. So I've been in the transportation side of things since 2014 when I joined Rensselaer to do my PhD. And after the PhD, it's not forever, although it might seem like it along the way. After I finished, I landed my faculty position here at the University of Missouri St. Louis. So that's it about me. Let's talk a little bit about urban freight issues. This is something that's coming at no surprise to all of you. There's deliveries in cities are super challenging. The trend is that as more of the customer consumption moves towards online deliveries, we see more of these smaller delivery trucks delivering parcels all over the city. However, this is not the sole source of freight traffic. There's a lot of freight traffic that is just going to need to be there to satisfy the basic, functions of a city. Freight is the manifestation of the economy, one of the big manifestations of the economy. So, of course, in a vibrant city, urban economy, you're going to have a lot of traffic. And, cities like New York, very densely populated areas, deal with congestion all the time. And freight is a major source of that congestion. So, there's been a lot of research trying to understand the problem and come up with potential solutions. Some of the solutions I'm summarizing here: congestion pricing, aimed at reducing the flow of trucks in congested highways or entry points to urban areas. That's been implemented in New York City, for instance, with the congestion pricing for freight, for trucks, delivery bans. We hear about these initiatives being implemented. One of the cities that I'm going to be discussing today has implemented delivery bans, which is Sao Paulo. Beijing also has delivery bans in its urban center. And these initiatives prohibit large trucks in urban areas. In general, these congestion pricing and delivery bans are not necessarily the first choice, although they are widely implemented. We all understand that trucks don't have a choice. So they need to come into the city to sustain the economy of the city. So most of the times the tolls are going to be paid because this is not going to necessarily create a big impact in reducing freight traffics. Delivery bans on the other side have other consequences, such as when the large vehicles cannot make it into the city, that cargo that needs to get there is going to get there anyway, but it's going to probably go in smaller vehicles and it's going to generate even more congestion. Anecdotally, our colleagues in Sao Paulo have told us that when the delivery ban was implemented there, large Coca-Cola trucks, you could see that they substituted for smaller ones, and you could see them riding in like a pellet, like one next to the other, just that instead of bringing one truck into the city, they were bringing two, because the freight needs to get there. The economic activity needs to keep going. So companies, suppliers, and receivers are going to find a way to get it, and you can get it unintended consequences. Parking is a really big issue in urban areas. There's, in general, the city infrastructure. If you think about New York City, there's just not a lot of parking space, and that's similar in most urban areas. In St. Louis, we don't have that issue. I can tell you that. We have so much space in the Midwest, so it's kind of refreshing. But most urban areas do have a lot of constraints regarding parking. So that's something that is really challenging to provide more parking, but it's still an option. And then there's the demand management initiatives, and demand management deals with the receiver, the last stage in the supply chain where we deliver the goods. The receivers have a lot of power in the relationship in terms of the decisions made in the form of the delivery, the time of the delivery, etc. So initiatives that aim at changing behavior in the receiver side can have big impact. However, we need to really understand their behaviors in order to be, just as I said before, in order to not incur in unintended consequences. Some of the demand management initiatives that have been implemented are changing time of delivery, consolidating deliveries among receivers, and staggering deliveries throughout the day. And these initiatives all have been proven to reduce congestion to some effect. And today I'm going to be talking about changing the time of delivery. What is the off-hour delivery program? I'm sure this is not the first time you've heard about it, so I'm just going to, set the stage. What the off-hour delivery programs want to do is, during the daytime when people are commuting for work, and there's a lot of traffic in the city. Freight traffic is going to, generate more congestion. Look at this picture here in New York. There's freight trucks need not only the space that they take in the street, but they also need to conduct loading and offloading activities. They need to park to do this, preferably close to the receiver. Otherwise, they're just going to stay longer or idle or drive around and generate even more congestion. So how about we try and move these deliveries that are occurring during the daytime to the off hours, to hours when there's less demand, less traffic in the urban area, so that truck drivers can have more availability of parking near the receivers and also travel in less congestion. We're not saying that we're going to move every single truck to the nighttime. There's going to become a time where we're just moving that congestion to the night, and there's going to be diminishing returns. And also, not every parcel can be delivered at night. Not every freight can be delivered at night. But we could target a big chunk of the deliveries to the nighttime and see and realize really important benefits in terms of reducing congestion. So when I joined Rensselaer Polytechnic Institute, this was already underway, and Miguel had worked on it. They implemented an off-hour delivery program in New York City, where several companies had been participating in shifting their deliveries to the nighttime. And amongst all of the work that was being done, there was this question of, we have this intuition that moving trucks to the night is going to be better for the environment because they're going to be traveling in less congested traffic. So they're going to be generating less emissions, right? So can we do something to quantify this? Is there a way that we can say, yes, trucks are going to move that travel in the nighttime and then make deliveries in the nighttime are generating less environmental emissions? So setting out to answer that question, we worked with partners around the world and at Rensselaer, and these are my collaborators on this project. And we worked in a setting where we already had a network of partners that had implemented off-hour delivery pilots, and I'm going to be discussing them throughout the presentation. So the research approach was laid out with the goal to compare the regular hours versus off-hour emissions of trucks making deliveries in an urban area. And so the first thing that we needed to do was we needed to find those trucks that are making those deliveries. So we define an urban area of interest, and we have to engage the receivers that are the ones that are getting the cargo in. And once we engage receivers and they're, they want to participate in the study, they are the ones that refer us to their suppliers. And these suppliers, we ask them to install the GPS devices. We went about this in all three of the cities that I'm going to be talking about today. And since this research was completed, we have replicated this approach in other cities, including Bangladesh and China. So after we have installed the GPS devices in the trucks that are making deliveries to the urban area, we collect the GPS data. So we just plug these devices in the truck and we let them collect data about their driving dynamics. Then there's this big process of cleaning the GPS data, and I'm going to talk about it because it looks very neatly there in a box, but it takes a lot of time. And then after that, we estimate emissions and analyze results. So they're pretty straightforward. We implemented this approach in three of our delivery pilots that were either underway or were already completed. The first that was already completed by the time we started this was New York City, where the data had been collected. Bogotá and Sao Paulo, Brazil, we were able to collect the data while the pilots were on their way. So in New York, in the New York City Offhour deliveries project, I don't know if Miguel has told you about this, because he's one of the guys that worked very prominently in this project. I'm just going to give you a quick summary in case you haven't heard about it. So the first phase of that of that program focused on staff of our deliveries. So there was incentives that were provided to companies to shift to the off hours in order to cover any personnel that they needed to have at night. And it was a pilot test that was conducted with 35 companies. After that pilot test, it turned out that unassisted off-hour deliveries was a feasible option, and companies that perform unassisted off-hour deliveries were more likely to remain doing off-hour deliveries after the pilot had ended, because they didn't need the personnel at night to receive the goods. So in the second phase, there was a focus on unassisted off-hour deliveries, and then in this case, 33% of establishments already have a trusted vendor, so they could do it without a problem. And the program was expanded, and it became one of the flagship programs of the New York City DOT, and it's still going. These are not very recent statistics. These statistics are from 2018. So I tried to look them up, but it was kind of late because I tried to look them up today. But I assume that there should be more, because it was something that New York City DOT was pushing, and a lot of companies that had either off-hour operations or had trusted vendors were still participating in the program without incentives at this point. It was just, that behavior change happened with the pilot, and once the benefits were realized, because there are other benefits besides the ones that I'm going to discuss today. Of course, there are cost benefits, and a lot of drivers prefer driving at night in congested areas. So after those benefits were realized, many companies remained in participating in this. And then we have another pilot, which is in Bogotá, Colombia. Bogotá is the capital city of Colombia. It's very congested. And there are these areas, such as this one, that are commercial areas, all parts of the city where the streets are very, very narrow. And there's just a lot of commerce going on. So this area was selected because of the high vehicle attraction, and also because of the layout of the urban area. And companies were recruited, but in this case, because of security regulations, the shift was not completely. So they started at 6 p.m., which is still considered, peak hour. So they experienced some congestion, and we'll see how that impacted the results, because they didn't shift completely to the off hours. And in the third city we have is Sao Paulo, Brazil. And as you know, in Sao Paulo, there's a traffic ban. So as I told you, there's a traffic ban, there's a truck ban. So there have been several policies that regulate truck traffic. In this case, this implementation was all volunteer companies that were working with the traffic authority, Metropolitan Transportation Authority, to test off-hour deliveries. And interestingly, some companies we were not able to put the GPS devices in the trucks, so we had to, the local team had to shadow the trucks with GPS measurements. That was a story for another day. Now, after we have engaged receivers and installed GPS devices, such as we did in these three pilot programs, we collect the GPS data for the duration of the study period. We aim to collect data for 2 weeks because routes are not going to be the same every day. So we wanted to have the ability to estimate performance metrics, not only the ones that I am presenting here, but also reliability and buffering and other supply chain metrics. So we let the GPS devices in the trucks for a couple of weeks in order to do that. And the GPS data collection, we had these GPS loggers that are very, very small, but also are able to collect GPS position data second by second. And this is key in this research where we're trying to estimate emissions, because emissions are really related, are very directly related to the acceleration of the vehicle. You may be aware that a lot of freight vehicles have onboard GPS devices and report this data to their companies. However, the intervals in these onboard devices, or the monitoring system that are used in the private sector, are not as fine-grained as what we would get with this GPS device. The GPS device is really, you can, as you can see in this picture, you can put it anywhere. It requires like the lighter plug to charge, but it was, we were able to collect very fine-grained, detailed data using these devices. Now, I'm going to talk about what happens after you get the data. So once you have a raw GPS data file, it's not as easy as just using that and estimating emissions. So once you have the raw GPS file, there's a lot that needs to happen before we can get robust results. And the first stage is formatting, validating the data, associating with vehicle categories, and understanding whether we have good data or not. And when I say this is because there are, times where the GPS is not collecting data, so you lost that route, or you have a lot of interference in the bouncing of GPS signals, and you don't have data that can be used for the purposes of the study. After we formatted, we identify the routes. So since we leave these devices in the truck, every time the truck is turned on and off, it's going to create a new file. However, we within one file, we can have multiple routes. So we do a first pass, and we identify the routes that are in the origin and destination in the file, and we split it. Once we have them split, we identify stops, and that's another research on itself, because identifying stops is not as straightforward as the vehicle speed is 0. It could be that the truck is standing in a red light, and you need to count that as part of the emissions that are being generated. Now, I'm going to illustrate a little bit of this. So we develop algorithms to identify automatically stops based on the GPS data. And if you look at it here, this is what the traces of the GPS data from a truck traveling look like, making deliveries in a city. And then you can see that there's portions of the data like this, where there's a lot of spacing between measurements because the truck is traveling in free flow, so there's no congestion. Other instances like this over here, you can see that the data points are clustered next to one another. And when you estimate the traveling speeds, it might be super low or even close to 0. But this is not a stop. This is a congested portion of the road. Then this cloud over here is what I was referring to as the bouncing of GPS signals. Now in here, we can see that it's because the truck was making a delivery in this location. Other times you would get, really weird random data points. And in those cases, it was impossible to understand what was going on. So, we already cleaned it at this point. And with the algorithms we developed, we use like this same mechanistic properties of the trajectory of the vehicle and the speed that it's traveling. And we implemented supervised classification, and we are able to determine, well, this is a delivery stop, this is congestion, this is free flow. So after we have the data cleaned and categorized in that way, we can estimate the emissions. So how do we go about estimating emissions? After doing a lot of research, at the time there was Moves software was available, but it was not as fine grained. This paper was published in 2016. So I'm sure that Moves right now, and I've seen it in action, has capabilities to do similar work than what we're doing. But at the time, Moves only the Moves emission software was not able to estimate emissions for such fine-grained detail. So it would only had an input, which was vehicle miles traveled. But this is exactly where the question that we're trying to answer. Is it the same if you travel those miles during the day or during the night in terms of the emissions that the vehicle is going to generate? So what we found was that California had published an MFAC database. So it's a emissions factors database based on fuel and vehicle types and driving dynamics, namely the speed of the vehicle. So if a truck of X characteristics is traveling at a certain speed, that means that it's going to be generating this quantity of CO2 or other emissions. And so we use those factors with the second by second data in order to estimate second by second the amount of emissions that the trucks were generating. Using that, we can also estimate fuel consumption because there's a relationship between CO2 and fuel. Today, I'm focusing on the emissions. Now, I'm going to talk a little bit about the New York City results, just to illustrate the type of data that we were looking for in a, one route. So in New York City, we had, I picked this route because we had a lot of different, environments in this one sample. So as you can see, this delivery has a long haul part there. The truck is coming from Pennsylvania, New York border. So it's traveling a long way to make deliveries in the city. This is data from the pilot. It's a company that regularly makes deliveries in the city. So this is a normal route, and the truck is traveling a very long time. So we were able to compare the long haul aspects of the trip. However, when we were looking at the route and we were categorizing it as an urban route, we do understand that even urban routes have to travel in uncongested areas to reach the city. But this is, really dwarfs everything else that's happening here. So we simulated a distribution center closer to the city for routes that were like this, that had just such a big long haul portion. And then once you look at the emissions in the city itself, you can see that the graph is showing you just how much more emissions are being generated in the urban area itself. because the truck is traveling in really congested traffic. So while the truck was traveling in the highways, reaching the city, this is pretty uniform. The emissions that are being generated are very close to free flow. Over here, then you can see where it's idling, probably it's stopping or it's traveling at very low speeds, and the emissions that are being generated are just a lot higher. Now, the results from the New York City Offhour deliveries were interesting, because this was a really big project, and we took a very close look at it. And we learned a lot of things from particularly from New York City. As you can see here, this graph illustrates how Offhour delivery routes travel a lot longer distances. Since the trucks are traveling not in uncongested traffic, they're able to make more deliveries and travel more in the same shift, right? So imagine like this is a driver's shift and this is another one. The red ones are the regular hours. The drivers during the regular hours are traveling in less, are traveling along much shorter distances, and are generating relatively the same or more emissions than the off-hour delivery routes. You can see here, everybody here in these routes is affected by entering the urban area, and that's a very common problem in urban areas. Here, entering Manhattan in the Hudson River, it's just always very congested. So what did we found in terms of emission reductions? Whereas our hypothesis correct? Does traveling, making deliveries during the night reduce the emissions that are being generated by the truck? Well, we found that by if we look at each the routes, all of them achieved a significant reduction in emissions. In New York City and Sao Paulo, it was extremely high. Well, at least it was surprising for me. I did expect to see reductions, but these are just very, very high. We double check, triple check for, So we had 55% CO2 reduction in New York City and 42% reduction in Sao Paulo. In Bogotá, it's a lot less, as you can see, around 13%. And in the beginning, I hadn't realized that this was partial Offhour deliveries when I was doing this research. So I was like, what's going on? But then I looked at the data more closely, at the GPS data by, time, and I plotted it. And then that's when I realized, oh, this is a partial. So they called it Offhour deliveries, but it was actually partial because they were still traveling in the congestion portions. And even though it was partial, they were still able to achieve significant reductions. I mean, 13% less emissions is still a pretty big win. Now, why are these emissions lower? What is the reason that traveling at night is generating these lower emissions? It's because of the driving dynamics. So when the truck is driving in congested traffic, it's going to be accelerated and decelerating more frequently, and that is going to be generating the higher emissions output. And when you look at the probability distribution of the instantaneous speeds and you compare it between off hours and regular hours, during the off hours, they're traveling more stable. And that's what's leading, and they're able to achieve faster speeds for longer periods of time, and that's what leads to the results that we have. So after we had these results, we were looking at whether we can use the results that we achieved in other cities for which we don't have data. Like, let's say another city wants to think about implementing Offhour deliveries. how about what is the benefit in terms of emission reductions that they could generate, that they could expect. And making a lot of assumptions and using freight trade generation, we not only created a model, but we also went really ambitious and looked at what would happen in all metropolitan areas in the world if our deliveries were to be implemented. And we looked at the rates that we had based on survey data that had been collected by either the Rensselaer Polytechnic, the Center for Infrastructure at Rensselaer, or our partners around the world. And we could see that the freight trip generation, or trips per day, had these relationships with the population of the urban areas in the USA and in Medellin. And then in terms of deliveries to households, we also had data for USA and South Korea. And using that data, we made other assumptions in order to estimate the global impact of implementing of our deliveries. So we looked at a stable FTG rate, which was much lower than, because we're looking at lower bound at this point. This is not precise, but we're looking at a lower bound so that we can promote like this type of initiatives and get a sense of how much these benefits can bring about. So in developing countries, we looked at a rate of 0.03 deliveries per person per day, whereas developed countries was 0.06. And then each delivery generates 1 additional kilometer of travel. 30% of the deliveries are made with mid-sized trucks, like those used in the research that I presented. And we just estimate a switch of 10% of the deliveries to the off hours. Now, using these assumptions, we find that in the countries that are best, so we looked at all metropolitan areas in the world, and the top 10 countries that stand to gain the most from implementing these off-hour delivery initiatives are United States, Mexico, Brazil, and the ones that you see here. It is not, some of them are a little bit more surprising than others, like over the Southeast Asia. That was surprising to see. However, in the developed world, where there's a lot of population density, or in the developing world in this case, where there's very high population density, it was somewhat expected that we will see these large benefits. And this chart summarizes these benefits that we estimated. And when we were conducting this research, we estimated that if 10% of the deliveries were to move to the off hours in the cities considered in this research, in the largest metropolitan areas for each country, there would be significant reductions that would get us really close to Paris Agreement levels. It was not enough, but it was a significant portion of the transportation-related emissions. To summarize, off-hour deliveries can bring about tremendous emission reduction. We estimate that partial off-hour deliveries can reduce CO2 emissions by 13%, while full off-hour deliveries can reduce it from 45 to 67%. And we could, if the 10% of deliveries were moved to the off hours in the top 10 cities, 70 million tons of CO2 can be removed from the atmosphere. And with that, that's all I had to share for my presentation. Thank you for listening to me, and I will take your questions. I'm going to stop sharing my screen. Okay.
Questions? I noticed that the top 10 countries for savings for switching to off-hour deliveries kind of lines up with the top 10 largest countries in the world by population. Was there an analysis of countries that would have an outsized benefit relative to its population?
No. And that's, it makes sense because we were using flat rates in terms of population. So we were just looking at the consumption of that metropolitan area. So that's a very interesting point that we could undertake to see where are other interesting, potential places where there will be even more incremental benefits. Yeah, good point. Thanks.
Thank you.
So I had a question about how do I compare the distance versus CO2 emissions to the total reductions? Like when you're saying like New York City had a 50% reduction in emissions, is that comparing a single route to, during regular delivery hours?
It's the rate. It's the emissions generated by kilometer. In the paper, we have all those tables. So we estimated rates, like how many grams of CO2 will be generated by a truck traveling in regular hours per kilometer and off hours. And that percentage is based on that reduction.
Okay. So reductions would only happen if total VMT doesn't go up.
No, they happen because the rates are going to be different during off hours. Let me pull up the paper. So the rates are going to be different between off hours and regular hours. So VMT is going to, if you travel more during the off hours, you can still even generate less emissions because that rate is going to be 65% lower or 55% lower.
Okay, thank you.
Does that answer your question?
Yeah. Thank you.
Mm-hmm. Okay.
The data was controlled for assuming that they're going to keep the same technology, right? The vehicle.
Yeah. It's at that point in time. So there's a lot of research that can be done looking at different technologies. And we were looking at the fleet configuration that we had data for, which was at that point that the pilots were made. So that there's even more, or I don't know, we can look at that question. Yeah.
Do you know what the suppliers' reactions were to these ideas of off-hour deliveries? Like in terms of, I would assume that misplaced packages would have a higher chance if you're delivering them at off hours.
Yeah. Well, in this case, we're not targeting deliveries to households. So it's commercial establishments, and it's a different type of cargo. And most of the ones that remain participating in the program were able to access the storage. So they were not leaving it on the curb because these are deliveries to commercial establishments. So and everybody that's drivers and suppliers are very happy because this type of program reduces their costs. The main barrier are the receivers. Yeah.
Right.
Who was paying for the extra hours of the people that have to receive the cargo? And how was that arranged so that it was beneficial economically as well?
The USDOT, right, Miguel? That was a program.
The USDOT was giving grants to Rensselaer, and then the project was providing financial incentives to the companies that participated. Some of them used the money to offset the additional cost. Some of them pocketed the incentive. But we found out that we also developed an unassisted Offhour delivery project where there was nobody needed to deliver at night through an additional program called the Trusted Vendor Program, where there was kind of this engagement between the receiver and the carrier company. And in some cases, they gave the key to a double-door system or any other type of system to provide the goods in the off hours. So no one was needed in the off hours to do it. And for the most part, most of the companies that are doing off hours today are doing in some sort of unassisted program. However, from some of the companies that Trilce mentioned, some of these large chains, especially the large grocery stores, they may be already open 24/7 or extended hours, and they were able to fully use their resources to receive the cargo, and it was beneficial for them. And in fact, I don't think we gave incentives to them because they didn't need it. They were able to find their own benefits by participating.
And in the other countries?
And in the other countries, it was case by case. In Bogotá, they gave some sort of incentive, and I don't remember how it was done in Sao Paulo.
Sao Paulo was voluntary.
Voluntary, yes.
Yeah, true. Yeah.
And there were two cases in Sao Paulo. One was during the World Cup, and then the other one was the university had connection with companies that participated. More questions?
Did you consider any rebound effects? I mean, in principle, if you're moving traffic out, then in principle you have room for more traffic so you're creating more traffic. I mean, maybe with the few trucks you moved, it didn't matter, but if you do it around the world and move a lot of trucks outside, people might drive more.
I can't hear the question. Can somebody?
The question is about, in this particular study, did you consider rebound effects? I mean, improving freight, did that induce additional traffic?
Yeah. No, we did not consider them. This is just direct impacts. Thinking that if you move the truck, this is the reduction that you can expect. Just the trucks. But yeah, of course, more advanced modeling could lead to understanding what's going to happen if we remove the trucks and you get other traffic. We see that happen all the time in transportation. So that's good for a follow-up.
And we have an analysis on that for San Francisco. And then we couple with probable demand management for the passenger side and pricing.
There you go. You did it.
For companies who didn't participate in the program after the end of the pilot study, what were some of the reasons other than not being able to do unassisted and needing additional staff at night?
That was the main reason that was reported. Yeah, they did not have there was no benefit to them, and it was a cost. So they were not interested in incurring in those costs. These were mostly smaller establishments that did not have infrastructure or trusted vendors that they can let in to their storage facilities.
Thank you.
To sort of follow up on the questions, what cities would you like to see this research repeated in to verify the models?
At this point, they've had, Rensselaer has partnered with so many cities. I believe DC, London. I've participated in Beijing, Bangladesh, Dhaka. So I would like to see European cities because they are very much different. So I'd be curious to see what happens there. And they use different size trucks, so it'd be interesting to compare because the global estimates we have are just really general, but if we can get data from other cities, we could get more robust results.
It was just about a comment on the question about what countries differentiate effects, because Italy is much smaller than France and Germany, so in principle you do have 25%. So the first question, you do see differentiated effects since Italy is top 10 and France and Germany is not. It was just so it was just.
Yeah, sorry. Comparing the vehicle sizes, because Brazil does have large truck ban. So could you compare what the effect was in a city that has smaller trucks compared to maybe New York that maybe doesn't have the same ban, or I don't know. I'm thinking of what happens when those additional size for trucks are in the cities are, and if you get a difference.
Yeah, we did those analyses, and we haven't published them for Brazil, and we did find that there was just significantly more emissions with the ban policy. So, but I haven't. They're not pre-reviewed. We haven't published them, but as part of this project, we did those analyses. Yeah.
And I don't remember about Sao Paulo, but I know in Curitiba, the bans were by time of day, I think until 10 p.m. I don't remember if in Sao Paulo, they also have kind of that time window where trucks are not allowed within the control zone. But something that we found in New York as well is that they are able to use even larger vehicles in the off hours because they are not capped on the congestion and they can do more drops.
Yeah.
So there are benefits there.
It's very common to put those bans. Well, Colombia has been doing them as well. So it's like, is it good or not? Like to actually incentive to change to smaller vehicles and have more trips, or have the bigger vehicles and have this.
But I think Chris is going to agree with me. I think every time we constrain the truck size, we're going to generate more BNP and aggregated emissions.
Yeah, exactly. Like I said, preliminary results that we've run that show that. We haven't done an exhaustive study, but it's a good hypothesis to go ahead and explore. Yeah.
We have a question from the audience.
Yeah, there are a few questions in the Q&A. One of the questions are, why wouldn't off-hour deliveries have more benefit in Europe?
Oh, they would, but when with the data that we had, they just didn't come up with it in the top 10. But they'd have a lot of. Like, did you see the graph at the end? Let me pull up the slides again. Yeah, they do. I don't know where that confusion came from.
I thought it was there.
Yeah. Let's see. Do I read the questions?
Yeah, if you wanted to go look at the Q&As.
Okay. Is the size of the delivery vehicle scalable to larger or much smaller? Yes. So the data that we had consisted in mid-size and large trucks. And the database that we use has all sizes. So the methodology, you can use it for any type of vehicles. In Bangladesh, which was the last time I implemented it, we had to use quite different vehicles. And so it's, same methodology can be used for any vehicle size. The next one says, are exemptions made for idling during off hours, such as in New York, where it can be illegal to idle for extended durations of time? So it can be illegal to idle, but freight vehicles do it all the time. They double park, they just cruise finding parking. So since the data is just characterizing these dynamics, we are capturing the idling. So there's no exceptions that we are including in the modeling. We are capturing that in the behavior of the trucks with the data that we collected. And then next question, can you expand on the type of incentives that were used in the pilot project? What was the success rate of the incentives? So Miguel will have better answers. I know that it was a monetary incentive, $2,000, but Miguel was part of that project. So I believe the success rate was every company that was offered implemented the off-hour deliveries. So 100%, but I don't know if there were some rejected it. I know there was a lot of research that was done to come up with the amount and which companies will be more likely. So maybe, Miguel, you can talk a little bit more about that.
Yeah, so initially we had a larger set of different types of incentives that included tax breaks, that included helping with retrofits, direct financial voucher or money. And initially we tested giving the incentive to shippers, to carriers, and to the receivers. But we found out that we only needed to incentivize the receivers. As the receiver of the cargo was in the firm, they will pull the rest of the supply chain. Because they were the ones mandating the frequency of the delivery, the location of the delivery, the time of the delivery. And so we didn't need to incentivize the rest. The willingness of the receiver to participate was enough. There were some instances in which, let's say you have a carrier company or a shipper. In some cases, it was the shipper and the carrier was the same company. That they had 10 clients and only one wanted to participate. Maybe in those cases, it wouldn't make sense for the shipper to participate because they will have to send during the day to 9 clients and then at night during the one that wanted to participate. So in those cases, we tried to put that client at the end of the route. So when the route was already under hours, when we couldn't do that, then that person or that company didn't participate. Now we tested different levels, and there was a lot of state of preference surveys conducted. And based on modeling, we found kind of the hotspot on how much we needed to give out to entice some participation in the project. But the initial phases of the project was a lot of legwork, working directly with the company to see not only the incentive, but maybe sometimes they needed to change the sign on the street to allow their truck to park at that night. Or as I mentioned, for the unassisted, sometimes they had to make retrofits to expand a walk-in refrigerator to have more capacity. And then we work with the company, we work with our office in New York to find additional money for them to apply to those grants and build those things. Again, initially it was a pilot project. That was when I was in there. We worked with the companies to get them in. Then we realized that the lowest hanging fruit was identifying those companies that will be able to participate in the unassisted of our delivery. And then a lot of the constraints that we were trying to fight over were not there. So it was easier to get them going. But yeah, we tested different levels of money. And at the end, that was the best alternative that, based on the response from the surveys we found.
As you can see, I joined Rensselaer when Miguel was leaving for California. So he did the lead work, and I joined when I had all this data, and all I had to do was research. So thank you, Miguel.
I had a quick question about like banning large trucks. Is it necessarily worse if like a large truck trip turns like two smaller vehicle trips? And I'm wondering because maybe smaller vehicles have better fuel efficiency and also they're less damaging to roads.
Well, what we found is that even though smaller vehicles may have, if we're comparing same technology, because you know that if you have newer technology, you're just going to have a lot more efficiency. But let's think about same technology. The larger vehicle is just going to be more efficient because with one trip, you're just going to have a lot more coverage. Whereas if you have two smaller vehicles to do the same deliveries, then even though the smaller vehicles is more efficient than the large one, when you add that up, it doesn't cover that difference. Do you understand where I'm going?
Yeah, I'm wondering like if like there like maybe like there's some other efficiencies that like if there are two vehicles and they can like they can go to different parts of the route. If you look at it maybe from a life cycle emission standpoint, like maybe the road gets less damaged, or maybe people are less induced to drive on the roadways, and maybe because there's more congestion, so they take public transit. So I was just wondering what your thoughts were.
Oh, yeah, those are all things that we can consider. But in terms of the focus of this research, which is the emissions itself, and like I said, it was actually not the focus of this research. We did look into that because it was a question for our partners in Sao Paulo. that what happens with this truck ban and what we're seeing shifting to these smaller vehicles. And if it was because you shift to smaller vehicles because you have less cargo to deliver, then great. But if you have the same amount of cargo, it's going to be better to use the larger truck, because then you will have just less emissions. Yeah.
Let me
Go ahead.
Add a little bit to it. So let's say we have two extreme cases. We have the extreme case in which you have a small owner operator, a small company only has one truck, and that truck is a 20-ton truck. And they just have one shipment that is 1 ton. And they use that large truck to come in and deliver that 1 ton. If you spread the emissions, the impact of that truck for over that 1 ton, then you're going to have huge impact per unit of capacity, right? Now, you may have a larger company that have a lot of clients or a large client, and they send the same 20-ton truck fully loaded. So in that case, that the impact per ton starts to become really low. What happens when you enforce some vehicle weight or size constraint in a location? You may be getting benefits avoiding that inefficient use of a large truck from the first case, but then you may be making the rest of the system inefficient, because to distribute those 20 tons for the other company, now they need to send 2 10-ton trucks. And the overall impacts and emission from the 2 10-ton trucks is going to be higher than the one single 20-ton truck. And I remember in Sao Paulo, Coca-Cola was showing that they were, instead of sending one large truck to distribute to a supermarket, they had to send 3 smaller trucks, one next to or after the other, to go to the same location. And I also remember I was visiting in Gothenburg. They have an urban consolidation center that the city was trying to for the downtown. So trucks come to this consolidation center, and then they get the cargo is put in some sort of small train, but it's not a train, it's over the road, but it's a small vehicle with some wagons. And the guy was saying, for the most part, it works. But the day we were visiting, there was this large truck that came in. They had to unload that large truck that was only going to one destination and put it into a lot of wagons, and then send that vehicle back, reload, and then set it again, as opposed to sending that large truck just to the destination. So I think the devil's on the details. But for the most part, we assume that companies are rational and they are trying to maximize profit, they will tend to use the best vehicle for their needs. Because if you use a larger vehicle for a small cargo, your cost is higher for that cargo.
And research has shown that, like there's papers from our advisor, Jorge Veras, where that the market is not failing there. You know, the companies are always going to be the most efficient one, because otherwise their costs are going to go up. So for the most part, you know. So I see some questions in the chat. One says here, please elaborate on the smaller vehicles in Bangladesh. If I said smaller, that was not what I meant. It was different. So in Bangladesh, there's a lot of older trucks. So we had to pull more data for those older vehicles. And we also had to consider other types of vehicles because there was refrigerated cargo. So it was just a little different. And that's what I meant when I made that comment. Were there any unintended noise complaints from overnight deliveries? Yes, noise is one of the biggest impediments of moving off deliveries to the off hours in cities where there's mixed land uses. There are a lot of technologies that have been developed to reduce these noises. Some that are especially when the truck opens I don't know the name, the door in the back, hatch door. So that's really loud, and that's the one that residents complain the most. So there are technologies to make that much quieter. There are things for when what's the name? I can't remember
forklift, the cart.
Yeah, the cart, to make it so that it doesn't make as much noise. And as part of the project, there was a smaller sub-project where data was collected regarding the noise. That one was funded by NYSERDA, I think. Yeah. So there is research there. I didn't participate in it, but yeah, that research found that the use of these technologies to mitigate the noise made it so that the barrier was eliminated.
I think the term you guys were looking for was either an order picker or a pallet jack.
Yeah.
I know that because I drove one for Home Depot back in the day.
Sometimes my English words get out of my head when the Spanish word comes in first, and I can't remember the English word.
It happens.
Are there more in the chat?
There's one more in the Q&A.
Okay. So if the transportation system is designed for smaller vehicles to facilitate walking, bicycle, and tricycle use, which necessitates smaller delivery vehicles, might the comprehensive impact of smaller delivery vehicles be different? Well, that's one of the big questions that we have in the urban freight space, the need to accommodate for all the uses that streets have in urban areas. There are reasons, this is not a one-size-fits-all answer for a city. There are places where having complete streets will be very detrimental for freight traffic and would not be advisable because, it will really impede the performance of freight systems. Other places, then freight can be accommodated with these other land uses. We don't have an answer to that question at this point. It's something that is ongoing.
I will say we need to complete the complete streets to fully include the need for freight.
Yeah. Yep.
Well, the question.
As a follow-up to that question, are there any examples of how cities like Barcelona with the super blocks or places in the Netherlands handle that issue, where they have neighborhoods that are not conducive to taking big trucks?
Yeah, I mean, I don't know about those specific cases. I do, I'm aware of discussions in the US with this situation. And at the end of the day, it's like Miguel said, the streets should be complete when we consider freight as well. So it's important. All these are important considerations, but at the end of the day, we need to weigh them, and it's not one size fits all. So I'd be interesting to see if these projects in Barcelona and the Netherlands are having some analysis regarding what the impact of these models are on freight. That'd be really good to see. Yeah.
I have a question, Trilce. Mm-hmm. So from all the work that you have done related to Offhours and what the other groups have done, what will be the most important advice that you will give a planner in a city that is interested in doing Offhours?
Interested in Offhours? Yeah, well, I've been thinking about that lately because I'm doing research on parking. And I think even though you want to do Offhours, we sell it as, you have more space to park. It's still one of the big things to incorporate, those infrastructure for parking, etc. And then community engagement, like you said, the legwork. It's something that has to be in the whole process. When you have the community engaged, then you can consider the particular needs. So it's transversal to every freight policy initiative that you're going to be implementing.
Can you share how Offhours can also accommodate other modes of deliveries?
Now with delivery lockers and other initiatives, we can also make household deliveries. That's just very interesting right now. It's a big issue that we did not consider that much in our project, because at that time we were mostly looking at we were only looking at commercial establishments. And so these solutions that are coming up for handling household deliveries should also be thought in terms of how can we move some of these to the off hours. We're like the same with the commercial freight. We're not going to move everything, but we should look into it, because it is becoming a really big demand of resources and a lot of freight. That is traffic that's being generated by household deliveries.
Okay. Any more questions? Well, if not, thank you so much, Trilce.
Oh, thank you for having me. It was so nice to have all these questions. It's been a while since I've done this research, but it was just really great to discuss it with you. I appreciate your engagement, and I'm just really happy that you had me today.
Thank you so much.